couple of years ago, right around when the Steam Deck came out, I made a poor man's version out of a Raspberry Pi and some old Xbox 360 controllers to stream games from my PC to a somewhat playable handheld device. While this project was very fun to make, it really didn't look all that great. And the controllers didn't feel great to use, especially when the solder joints connecting the two halves of the controller PCBs broke off all the time. I knew I wanted to revisit this project and make it much better than it was. I designed and printed a hinged Nintendo Switch mount last year, and it made me start wondering why in this recent influx of handheld PC gaming consoles we haven't really seen a hinged one emerge. The last one I can think of is the Nintendo 3DS, which had the last version released over a decade ago. There's currently a retro handheld called the Retroid Pocket Flip, but that isn't for modern gaming. While I don't think I have the capability of building something that can natively run current-gen games in a handheld form factor, I know I can build one that can stream from my desktop PC with basically unnoticeable input lag. This time, I wanted to make it something I completely designed from scratch, so everything gets put together much cleaner than the last time, which means I'm not using existing controllers. That being said, the first thing I actually needed to learn was how to design a PCB from scratch. After digging around Reddit for about 30 seconds, I saw a free software called KiCad recommended for anybody building PCBs as a hobbyist. After watching a couple of tutorials, I designed an atrocious looking PCB just to order and test to make sure it works how I expect it to. All I really did was put pinholes for an Arduino to go into, pinholes for buttons and joysticks, some mounting holes which I'd used for my final design, and then mapped out traces between the buttons and joysticks to the digital and analog pins on the Arduino. Once my test PCB worked, I spent a lot more time making one that uses silicone pads instead of normal push buttons to get the same button press feeling that you get from your average modern controller. This is the final PCB design, which I'm actually really proud of. It looks so much cleaner to me than the rat's nest of soldered connections on my first handheld streaming console, so it's a huge win. One downside of this controller design is that the Arduino Pro Micro doesn't actually have enough analog pins to fit the joysticks and triggers, which use potentiometers to provide varying analog readings to the control board. So the triggers are just buttons on this design, so you just press them once, there's no variable readings like if you do a half press on the trigger. Also, there weren't enough digital pins to fit all of the buttons, so I connected two buttons that you would never need to press at the same time. For example, the D-pad up and the D-pad down, as well as the D-pad left and the D-pad right. You'd never really need to press those at the same time, so I added them to something called a resistor ladder and then to analog pins. Without getting too deep into the electrical engineering behind this, it basically sends two different analog readings to the Arduino depending on what button is pressed, to the same pin. Using logic in the Arduino code, I can say if the reading is X, then that's the D-pad left being pressed. If the reading is above X, then that's the D-pad right being pressed. So the same thing for up versus down. The only actual issue with using a resistor ladder this way, if I press down on the D-pad very soft, sometimes it registers as up because the up reading is supposed to be a lower voltage reading than down. So if I press down and it's not making very solid contact, it's actually a lower reading than it's expecting, so it presses up. So it's not perfect. The same thing happens for right versus left. Both of these PCB issues come down to the fact that there are not enough pins on the Arduino Pro Micro, which is the one I use for this small footprint. I have an idea that will expand the amount of inputs on my next iteration, but for right now this is completely playable. For programming the Arduino to work like a controller, I use the X input library, which there are a few YouTube videos and instructable pages that I'll have linked in the description explaining how to implement. It basically assigns each pin to a button, and then I added logic for the resistor ladder that I was just talking about to sort through the analog readings for the D-pad button presses. After compiling the Arduino script, I used the website Gamepad Tester while the PCB was plugged into my computer to make sure everything worked. Here's where I noticed that the D-pad didn't always register how I expected on light presses. Once the controller PCB was working as expected, I picked out the screen and the Raspberry Pi that I was going to use. I wanted to start by using a Raspberry Pi 5 4GB since it was the newest one to come out, so I expected it to perform the best. I picked out a 7-inch screen that the Raspberry Pi is able to mount directly to and power via pins instead of a USB cable, and then connect to with a ribbon cable instead of HDMI for the lowest profile possible. With the components picked out, the next step was to get started designing the controller shell to package everything together, as well as the hinged connection to the screen and Raspberry Pi. The CAD software that I use is onshape, a fully cloud-based software that you can run in your browser. You can try Onshape Professional for 6 months for free using the URL in the video description. Here's the final design for the hinged handheld streaming console. I designed everything here within a single document, which made aligning all of these parts so much easier than normal. In other CAD software that I've used previously, I would have to have separate files for each part, designing them separately, and keep going back and forth between the part and the assembly files to make sure that everything fits. Here I can use the same sketch to make several features on different parts that mate together. While I do have an affiliate link with Onshape so my statements may seem biased, using this CAD software has helped me save a significant amount of time throughout many projects that I've been working on. Here's me hopping through the feature tree of the part studio so you can see how this design developed over time. I started by designing the controller shell, cutting it into 2 pieces for the front and the back, hollowing it out, and then cutting out holes for the buttons and the joysticks. Then I added holes for the bumpers and triggers and started working on the hinge and the screen. One other thing that I like in Onshape is that you can assign variables to your sketches and change dimensions on the fly, like you can see here with me changing the distance between the screen position and the controller. You can do this in some other CAD softwares, but everything is intuitively placed here and very easy to incorporate. If you're enjoying this video, make sure to like it and subscribe to my channel. I have a few videos in the works that are somewhat similar to this one, so turn on notifications and make sure you stay tuned for those. To finish up the design, I modeled a case for the screen to mount to that connects to the hinge on the controller. I added mounting posts for the controller PCB to mount to inside the controller shell, custom buttons, and a cover for the back of the screen and Raspberry Pi. I made sure to add ventilation slots for the Raspberry Pi's heatsink and fan, as well as slots for cabling. Now with all the designs finished, I got started printing everything out. Don't forget while watching this video, this project did not go as smoothly as it seems. I have the power of somewhat okay video editing to make this video not drone on too much. You can see in this picture just how many design changes and 3D prints that I had to test out before getting to the final model you just saw. So next time you're working on something and it's not quite working out the way you thought it would, just know that it happens to everybody, and when you learn how to resolve those issues, it gives you the experience to avoid them on your next project. Now I think we're ready to put this whole thing together. First, we have to put in the triggers and the bumpers. The trigger has a pin that slides into a hole on the bottom controller shell and then presses into an undersized hole in the trigger. I made sure that this pin fit nicely to avoid the triggers from rattling while you're playing. The bumpers just kind of slide into the cutouts on the top of the bottom shell and then rest on the buttons soldered to the PCB. With the bumpers and triggers in place, the PCB gets tightened onto the mounting post with screws. I'm only using 2 screws for now since that's enough to hold it pretty tight, and it's a pain to undo more than you have to when I know I'll be disassembling this to test it out a little bit more. The buttons are actuated by pressing down on these silicone pieces with black conductive silicone pads that you can see through them. This shorts the 2 square pads that I designed on my PCB and registers it as a button press. To put the buttons in, I carefully put the silicone pieces onto the buttons when they're pressed into the top shell of the controller, and then carefully align the bottom to the top shell. This part is the most annoying in the whole assembly process, so I'll see if I can fix that in the next iteration of this project. With the top and bottom shells pressed together, it's time to hold them in place with 4 screws coming from the back side of the controller. Once the controller portion of this design is assembled, we can secure the screen's frame to the hinge. I use a long screw and a nut pressed into the screen mount. I also use nylon washers to make the hinge rotate a little bit smoother than if it was just the 2 3D printed surfaces rubbing together. The layers on the 3D printed parts make it not as smooth of an experience as you'd like. Now we can mount the Raspberry Pi and screen subassembly to the screen mounting frame. We just slide the cables through and then hold the screen in place. To secure the screen, we take the back cover and put it in place and use 4 small screws that thread into posts on the screen. This clamps it to the mounting frame. I just have to make sure the cables for powering the device and connecting the controllers are routed properly through the cutouts that I designed before I bolt it down, and then everything's assembled. The last thing to do is plug the Raspberry Pi into a small portable charger that I found on Amazon that mounts to the controller with a magnetic ring that I glued to it, and then everything's set to run. This battery is a 5000 mAh portable charger that has lasted me about 2 minutes per 1% of charge as I've been playing on this, so there's a little over 3 hours of battery life on this when streaming games from my desktop. Also, I won't get super into the weeds of the software side of this project, but I have this set up to run a Python script at launch that opens a screen giving you the options of launching Moonlight, which is a software that can stream from your PC, going to the desktop of the Raspberry Pi if you need to troubleshoot anything or connect to Bluetooth for headphones or anything like that, and shutting down the device. If you click Moonlight, you can pair your PC and get started streaming any game installed on your desktop. You can connect over local LAN, or you can set up a VPN that's connected to your PC and the Raspberry Pi, which will let you play anywhere you have an internet connection. Obviously, the best streaming quality is when you're on the same network, but if you have a strong enough Wi-Fi connection away from home, it's a playable experience for sure. The input lag is barely noticeable when I'm on the same network as my PC, and to prove it, here's a decent combo in Tony Hawk Pro Skater 3 and 4 Remake, which you need pretty good latency I think to time tricks and grinds. While I'm extremely happy with how this project turned out, I think I can make it even better. Some upgrades that I have in mind is getting a higher resolution screen, adding more inputs to the Arduino for the controller to resolve some of those issues I mentioned earlier, adding more functionality to it by adding RetroPie and PlayStation Remote Play, which weirdly enough I was having trouble with using the ribbon cable, so I think I'm going to have to swap for HDMI, so I'll have to figure out how to make that not so bulky, making the battery internal and hiding the cables better to make it look even cleaner, as well as adding speakers and then a few other ideas that I have. If you're interested in any specific parts of this project and want to see me do a little bit of a deeper dive on anything, like maybe designing your own custom controller or any 3D modeling or Raspberry Pi details, or if you have any other ideas to make this project any cooler, leave a comment and let me know. If you enjoyed this video, make sure to subscribe and turn on notifications so you can see the upgrades that I make to the next version of this project. Thanks for checking out the video and have a great rest of your day.